Hello, hello. Good morning, good afternoon, good evening, wherever you're sitting at. Thank you so much for joining us today for this webinar on risk assessments, looking at the overview of the basic requirements. My name is Devin Murray. I have been with the company for going on 16 years, which has gone by really fast. Within those 16 years, 14 of those years, I've been within the Technicum division, where we handle what I say now, everything machine related outside of the actual product, right? So Schmersal manufactures safety products. And then the Technicum division, we deal with trainings like this, risk assessments and machine validations, and again everything around machine and plant safety. My education is electrical engineering, so I have my Bachelor of Science and my MBA from Alfred University, upstate Alfred, New York, and I do have my TUV certification for functional safety for machinery from TUV Rhineland. Um, so that's who I am, and let's go ahead and jump right into the webinar here. Okay. So if I were to ask you on this call here, to do a risk assessment, some of you may feel comfortable doing it. Some maybe not so much, which is maybe why you're here on the webinar. Maybe some of you, again, feel comfortable doing it, but maybe want to get another perspective on the risk assessment process, right? But if we say, okay, let's look at a simple machine, a drill press, and I say, okay, let's go ahead and do an assessment on that. We'll go to the machine, we'll look at it, and we can see, right, the point of operation. We can identify some moving parts, and we can say, yeah, there's some hazards associated with this machine, and we can go through that process, right? And what is that process? We'll get into, but off the bat, we can say, yeah, we can identify hazards with this machine. And then what if I say, okay, well, let's bring it up a notch. Let's look at maybe a machine that's considered a little more complex, and we look at a CNC machine. And I asked, okay, let's go ahead and do a risk assessment on this type of equipment. Again, some of you may have more comfort level than others. Now we're looking at hazards that are, considered more dangerous. And how do you feel about doing that type of assessment? And let's take it up even further and look at an industrial robot. Right now, we're looking at hazards that can cause a fatality. Right. So now, do you feel comfortable doing a risk assessment where we're looking at hazards that can potentially take someone's life? And these are just, standalone pieces of equipment, right? Some are more complex than others. And if we look at a plant floor, we may have the situation where there's a full line, right? There's a production line or a full-blown robotic cell with so many moving parts and moving machines. Are you able to do an assessment on that? Okay. And I'm going to say that it doesn't matter what type of machine you're looking at, whether it's a drill press or, something like a full-blown, industrial line or a work cell. The questions are usually, where do we start? Where do we start? Right. And part of the journey here within this short hour is helping you understand where do we start and what this process is. But for me to answer this question of where do we start, I first want to answer the question of what is a risk assessment, right? What is a risk assessment? And to answer this question, I'm not going to give you, my interpretation of this definition, or at least not yet. I want to look at the actual standards. Right? Let's look at the facts. What is a risk assessment? And to do that, I first bring up this international standard, ISO 12100. And I do this for a couple of reasons. Yes, we are a global company, but a lot of you on the call today on this webinar are part of a global company. And one of the things that we see within a global company is there's a corporate safety standard, and that corporate safety standard would reference a lot of ISO, a lot of international standards, so that it can capture as much audience as possible. So if you have a sister site in China or Europe or in South America and of course here in the States, these international standards kind of covers everyone to a certain degree, right? But ISO 12100, the full title is General Principles for Design, Risk Assessment, and Risk Reduction. So immediately we see that, okay, this standard deals with exactly what we're looking at today, right? Risk assessment. This standard gives us a definition of a risk assessment. That definition being an overall process comprising a risk analysis and a risk evaluation. Right? Straightforward, one sentence, right? That's the definition of a risk assessment. I want to look at another standard, right? We are sitting here, or most of us are sitting here stateside, where we look at OSHA and NFPA and ANSI, right? So I want to bring in ANSI B11 TR3, which is a technical report for machines. This full title is Risk Assessment and Risk Reduction, a guide to estimate, evaluate, and reduce risk associated with machine tools. All right. The definition from this technical report is the process by which the intended use of the machine, the tasks, and hazards, and the level of risks are determined. Okay, again, one sentence, kind of straightforward. We'll come back to that in a second. We do have our friends up north in Canada, right, that have the Canadian Standards Association, CSA. They have a standard as well. CSA Z432-16 or Z432-16, right? That title, straightforward, safeguarding the machinery. Okay, it is what it is. The definition: the overall process of hazards identification, risk analysis, and risk evaluation. All right, so now that we have all three on the screen, let's take a closer look at them, right? In all three of these definitions, we see that the risk assessment is a process. We see that in all three of these definitions, they mention the idea of a risk, right? We want to evaluate, analyze a risk. And on the ANSI and the CSA definition, they even go as far as saying hazard, right? What's a hazard? Okay, so let's look at what we mean by this. What do we mean by this? And if we take a step back and think about risk assessment, that term alone, right, kind of says what it is. We want to assess the risk. So the definitions that we see here probably aren't earth-shattering, but again, I want to show you exactly what's written in the standard. All right. Now, based off what we have here, I want to take a closer look at another definition, which are hazards and risks, right? Those definitions called out hazards and risks. So here are the definitions based off of those standards. First one, ISO 12100. A hazard is a potential source of harm. Okay. The risk is the combination of the probability of occurrence of harm and the severity of that harm. Okay, I'm going to list all the definitions, and then we're going to dive into this a little deeper. I want to list all the definitions first because as we see within this technical report, the definitions are exactly the same. Hazards and risks are defined exactly the same. When we look at the Canadian standard, there's just a minor difference, right? As far as the definition of hazard, they add in to a worker, right? Potential source of harm to a worker. And then for risk, again, a very minor change, they went from probability to likelihood. Let's look at an example. All right, let's look at these definitions and try to relate this to something that maybe we all can understand a little better, especially that definition of risk. right? So if we look at a, a horizontal lathe, as in this illustration, and again, I asked, let's do a risk assessment, right? So we go to the machine and we haven't gone through the entire process of the risk assessment, but we all kind of have a basic understanding that we need to identify what's wrong with this machine. So we can look at this piece of equipment, and by default, we will see some motion, some movement, and we can say, okay, yeah, there's a hazard. There's something that's wrong because it's not guarded, and we can easily access it. So maybe that this is considered a hazard, right? So we look at this definition, potential source of harm. We can say, okay, the rotating chuck, okay, that is a potential source of harm. What is the risk associated with that? All right, so if I make contact with this rotating chuck at full production speeds, what can happen? Right? What is the harm associated with that? That's part of the risk. Some of the other things we have to look at for the risk is what's the likelihood or the probability of coming into contact with that chuck. Right? We'll dive into more of those different elements within the risk, but again, 10,000 foot view for right now at least, it's what is the potential source of harm, which is the hazard, and then what can happen to us if we are exposed to that hazard. So now if I come back and say, okay, well, what is a risk assessment? So now I'll give you my my interpretation of this definition. It's a systematic approach or process to identify hazards and evaluate the risk associated with those hazards to determine necessary risk reduction measures. All right. We didn't get into risk reduction measures just yet, but this is what a risk assessment is. So let's now go back to the standard. What I'm showing here is a snapshot of the actual standard itself, right, for the risk assessment process. And this is just the fundamental steps of the risk assessment. Because if you were to look at this figure within this standard, it will be a full page, and there will be a lot of yes or no questions that will lead you to the next step of your risk assessment. All right. So again, this is just the fundamental steps. So ISO 12100, the fundamental steps for the risk assessment is to first determine the limits of the machine, which means really we need to define the scope of this assessment. Who is going to use this machine, right? What are the different operating modes? Where is this machine being located? Is this an off-the-shelf piece of equipment? Is this something that we've modified? Is this a custom-built piece of equipment, right? So we have to define the scope. This is what's meant by define the limits of the machine, right? Or some of what's meant by define the limits of the machine. Once you do that, once you have a scope, then you move there of identifying the hazards, right? Identifying the potential sources of harm. Once you do that, we then look at a risk estimation. So every time you identify a potential source of harm, you then have to determine what the risk is. And we saw the definition of the risk already, right? We have to determine what the risk is. And then we have to quantify it. Right? What does that look like? We have to quantify this risk based off of the probability and likelihood, right? We have to quantify it. Once we do that, we then evaluate it and say, okay, well, this is the number, but what does that mean? Right? What does that mean for us? That's the evaluation part of it. And then we ask the question, is this number good? Right? Is this risk acceptable for us, for your company, for your organization, for the site? Is this number good? All right. We'll go deeper into this, but again, I want to show you the three different examples here. For the technical report, again, this will be a full page, but I'm just showing the basic elements of the risk assessment, where, again, we define the scope or define the limits of the machine. Then we do a task and hazard identification. Again, what are the potential sources of harm? And then we do a risk estimation, which is the same idea, where we quantify the risk. And then we ask, is this number good? Are we okay with the level of risk that we've identified? Z432, identical, right? Define the limits of the machine, task and hazard identification, do your risk analysis. So they call it something different, but it's the same thing. Risk estimation, risk analysis, the same thing. And then we ask, are we okay? All right. If we take these three different examples and we throw them in a nice, clean table to show what the difference are, we'll have this. Okay. So at the very beginning, for all three examples that we show here, it's going to be the same. Define the limits of the machine. The very last step for all three is going to be the same. Is the risk reduced enough? Is this a tolerable risk? And then what's in between, slightly different, but the concepts are the same. Okay? So ISO 12100 says we're going to do a hazard identification and a risk estimation and a risk evaluation. Okay, fine. ANSI and CSA says that we're going to do a task and hazard identification. Okay, all three of those, we're going to see what the hazards are, right? And all three of them, we're going to do a risk estimation. All right, now ISO 12100, they break it up into risk estimation and risk evaluation, where again, we quantify it and then we say, okay, based off this quantification, where are we? And ANSI B11, TR3, and Z432, they have those two steps combined as one, as risk estimation or risk analysis. All right, we'll get into an example in just a second. Okay. Now, when we get into quantifying the risk, right? Quantifying the risk, what does that mean? What does that look like? All right. So again, going back to the definition of the risk, the likelihood or probability of occurrence and the severity of it. Okay. So when we look at the standards and we look at what they mean by severity of harm, well, ISO 12100 refers to the severity as something that's slight or serious or something that can cause a fatality. Right? The technical report says it can be something that's catastrophic or serious, moderate, or minor. Z432 doesn't really give a description, but more so that says that you want to use a scale. You want to use a scale. And the thing with that is you can use anything you want to use, right? As far as trying to come up with this estimation. You can use an Excel file. You can use what we're going to show here as far as some of the examples. You can use a third-party software to provide this risk estimation based off of the severity of harm and the probability of occurrence. But again, what I want to do is show you what's listed within these standards, right? For the probability of occurrence, that other element for a risk assessment, for determining the risk, 12100 looks at the exposures of a person, the occurrence of the hazardous event, the ability to avoid it, right? So, am I going to be exposed to this hazard? How often am I exposed to this hazard? If I am exposed to it, can I avoid it, right? That makes up the risk associated with it. All right, and ANSI B11 TR3 says very likely, or unlikely, or a remote chance. And then Z432 kind of mimics what ISO 12100 says. The technical report goes a little deeper and provides this table. All right, so based off this table, we can provide a risk estimation. So based off of the severity of harm, catastrophic, serious, moderate, and minor, and based off of the probability of occurrence, very likely to remote, that intersecting point will then give us this risk estimation. Right? This is just one example. You can use anything. Right? This is one example. Another common example within the industry is this hazard rating number, or HRN. Okay, and when you look at the HRN, there are parameters like the likelihood of occurrence, right? The likelihood of occurrence, going back to that definition of a risk, the frequency of exposure, again, based off the definition of the risk and everything that we saw on the previous slide, right? So likelihood of occurrence can be something that's impossible, cannot happen, to something that's certain, no doubt, that's going to happen. Frequency of exposure, infrequent, maybe some type of maintenance task, type of PM task, to something that's constantly happening. So throughout the entire shift with this operator. Degree of harm. Okay, again, going back to that definition of the risk, have something that can be a scratch or a bruise up to something that can cause a fatality. And then lastly, the number of people, right? Persons exposed. We're looking at the previous slide. Person exposed. How many people are going to be exposed to this particular hazard? Right. So again, this is just another example where we're trying to estimate this risk. Let's try to start tying some of this together, right? So throughout the risk assessment process, right, it's define the limits, identify the hazards, identify the risks, and then do a risk estimation to find out where we are. And then the question with all three of those standards, it's, are you at an acceptable level? If you are, perfect, right? That's the end. We document it, we move on to the next hazard or the next machine. But if it's not acceptable, if this hazard and risk is not acceptable, we then move further down on that figure. Again, I said, the figure that I showed earlier for the risk assessment, just one part on one page. Here are some of the other parts on that same page where we're saying, okay, this risk is not acceptable. We then try to see what can we do to eliminate or reduce these risks. And the first thing is, well, can we design this risk out? And then we start thinking about our control of hierarchy controls, right, for safety. And can we design these hazards out? Or can we do a substitution on these hazards for something that's a little less dangerous? And for new machines being built, we may have an opportunity for that. For existing machines on the floor, we're trying to do a risk assessment. It may be more difficult, right, to try to design a hazard out. Like, this machine's been on the floor for 5 years, 15 years, and we may not have enough justification to bring the machine offline to do a redesign. Okay, so on a new machine, more likely. Existing machines, less likely to do a redesign. What's more common on an existing machine would be adding some safeguards. So we can't do inherently safe design measures. Maybe we can implement some safeguarding measures, like some hard guards or some safety components. If we can't do that, the standard said the bare minimum is providing some information for use. Okay, I'll come back to this standard after I show the other two. Right, so the technical report, very similar. If this HRN, this risk is not acceptable, then we say, okay, fine. Can we design it out? Can we provide some type of safeguarding measures? If not, can we provide administrative controls, right? Some type of work permits and PPE and what have you. And you'll see that it's very similar with Z432-16. Okay. Now, ISO 12100 is really for machine builders. Right? That's reserved for machine builders. So you see at the very ending of it where we can't design it out and we can't provide protective measures, the last thing that's listed there is, well, let's provide information for use. Where TR3 and Z432-16 says, all right, let's use administrative controls because this is more for end users. Right? How do we fix what's there. Let's look at a practical example. All right, so we can look at a machine, right, a part of a machine, and we see that there is a cylinder moving up and down. Okay, we say, okay, let's do a 10,000 foot view, risk assessment right now for this webinar, right? So we look at the machine, we see some motions, and we say, okay, what is the potential source of harm? That moving cylinder, right? What's the risk associated with that? Part of the risk is, okay, what's the harm? Okay, so there could be some crushing there. The other part, the other elements of a risk is what? The probability and the likelihood of occurrence, right? We'll look into that. Here's that example of the hazard rating number. So based off of the previous slide, we can say, okay, we have a probable chance of being exposed to this hazard. So we have a value of 8, probable, not surprised. And we are exposed to this particular hazard hourly. And so we get a value of 4. And if we are exposed to this hazard, there's enough pressure on there where we can have a fracture, right? Enough pressure, enough force, we can have a fracture. That gives us a value of 2. And one person at a time would be exposed to this potential hazard. That gives us a score of 64. And again, this is an example. You can use any metrics you want, right? This example, we say, okay, we have a 64. Based off of that value, we do a risk evaluation, and it says that we have a high risk. All right. If we look at TR3, we look at this fracture hazard, and we say, okay, maybe that's going to be a serious hazard. All right. That's definitely not minor. We wouldn't call it catastrophic. We'll call it serious. It's a serious hazard, and maybe we have a likely chance of being exposed to it. Right? We say, okay, we have a high. We have a high risk. So we did a risk estimation to say that it's high. Now the question is, as we saw, is this good enough? Is this good enough for your site? All right? Is this good enough within your organization to have this high hazard? Now, if it is, you also have to justify that it is, right? In most cases, this is not going to be acceptable. So then we look into the other elements of the risk assessment, which is risk reduction. That is something that's missed quite often for the risk assessment process. Okay, the risk assessment is not just identifying hazards and risks. That's just one part of it. The other element is trying to correct it. Right? Let's add some risk reduction measures, and now let's see where we are with our risk estimation. So we have a high risk. Let's try to reduce this high risk. So let's look at some risk reduction measures. All right. So first thing we want to do, based off what we saw earlier, we want to see, can we design this out? We have a crushing hazard. Can we design this out? Here's an example. We change the shape of that cylinder. So we no longer have that crushing hazard. Do we have a pinch hazard? Maybe that's up for discussion. But that high risk of crushing has been eliminated. Right? That's the ideal solution. If we can design the hazards out, that's the ideal solution. Okay. Of course, again, for existing machines, maybe not so much. And even for new machines being built, we may not be able to design these hazards out. So we have to look at other risk reduction measures. This example, we're using hard guards. Right? Hard guards are going to limit access to this identified hazard. So we can have risk reduction by safeguarding. Okay. Again, depending on the machine and the application, sometimes hard guards are not going to be enough, and we have to implement additional safety components, safety circuits. We'll touch on that in a little bit. Okay, so risk reduction through safeguarding. The last thing, as we saw in the previous slides, risk reduction by administrative controls, right? So work permits and fines and PPE. Typically, what you'll see though, it's a combination of risk reduction by safeguarding. So you'll see some hard guards, and you'll see some safety components, and then you see a sign on that machine, right? You do not operate without guards in place, and there's a crushing hazard. So you see a combination of the two. But this is the idea: risk reduction. Okay, and I have a note here. Risk reductions do not change the degree of harm. They only change the likelihood of exposure. Okay, why? So if we look at our risk reduction options, so the hard guards and the administrative controls, we're not doing any redesigns of this initial hazard, right? That cylinder that's coming up and down. We didn't design it out. So the fact that we have hard guards there, that hazard still resides with the machine. If those hard guards were not there, someone took them off for maintenance, forgot to put them on, we are fully exposed to this hazard again, right? This crushing hazard that we just defined as a high estimation. Okay? That hazard, potential source of harm, still exists. The only thing that we did was safeguard against it to reduce the likelihood of exposure. Why is this important? Why is this a note? Why did I take the time to explain this? Because once you do your risk reductions, you have to do a recalculation. You have to reevaluate this risk. Because the question at the end of the assessment is always what? Is this risk acceptable? Okay, so we have to do our recalculation. So for our HRN example, it went from probable to highly unlikely. Okay, highly unlikely. So that's a 0.5. So you do your calculation, right? The way that we use the machine has not changed. Right, so we still use this machine hourly. All right. Again, that hazard still resides within the equipment, so we still have the potential, if exposed to this hazard, to have a fracture. It's still only one person using this machine at this given time that's going to be exposed. So now we have a risk score of 4. Right. So the only thing changes is the likelihood. We drop down to a 4. Okay. Again, using the table from the technical report. That severity of harm is the same. Right. We didn't change that. It's still there. The only thing that would change is the probability of occurrence. So maybe now it's unlikely. And so we went from a high risk to a medium risk. So now we may say, okay, is this acceptable? And in most cases, it is. Right? But now you have identified it. You did your assessment. You did your risk estimation, your risk evaluation, and your risk reduction. And now you can justify, you can document that we now have a very low or medium, based off these examples, of a risk. Okay, and again, you can use anything. The key thing is making sure that you go through this process, right? Defining what the scope is, what the hazards are, what the risks are, and then whatever numbers or methods you want to use so that you can have something to evaluate. We want to estimate the risk so that we can evaluate the risk. Okay? When you look at risk reduction measures, again, that's part of the entire risk assessment, providing a solution, right? You identified an issue. Now we have to fix it. That's part of the risk assessment, fixing the issue. So there's some things we have to consider with fixed guarding, right? So the example that we saw with the cylinder, we added some hard guards to prevent access. And I always say, when you start trying to do a risk assessment, let's lead with that. Let's lead with fixed guarding. and I'll explain why at the end of this slide. But if we look at fixed guarding, there are certain things that we have to consider, such as the height and distance to the hazard. Okay, a lot of times what happens that I see is a hazard has been identified, and a solution has been implemented without the proper engineering design. The problem with that is that it can cause this huge false sense of security, right? Because now, as an operator or whoever that's working on the machine, they'll see the light curtains and the guards and two-hand controls, and they assume, as they should, right, that this machine is safe, especially if this machine did not have those guards on it before. So you're going through the exercise of going through an assessment and providing a control measure. We have to make sure that it is installed correctly. So if you have a fixed guard on a machine, well, if I can easily reach over or around or through it, what exactly did we do? Right? Did we actually reduce exposure to this potential source of harm? Not really. So we look at the height and distance to the hazard, and there are standards that would help guide us on what those heights and distances are. Okay, we have to make sure we have the right material for the environment. Right? Is this a high pressure, chemical washdown type of environment, high temperature, high pressure with caustic chemicals? Is this an explosion-proof environment? Are we using Lexan? Can we use mesh? We have to make sure that we're using the right type of guarding. Important, right? We want to make sure that it's difficult to remove. We look at some of the standards. It will say, okay, make sure that we use fasteners that require a special tool for removal. And that just means that we want to make sure that the operator does not have a means to remove those guards. Right? So we're using fasteners that the operator cannot remove. We want to limit the interference of the process. So safety is first and foremost, right? We want to make sure that we're providing this safe solution to have this risk reduction. We also want to make sure that we are limiting, the interference of this actual process. I've seen firsthand where machines have been safeguarded to the max. So much so that machine can no longer be used as it was intended to be used. And that machine was tied off and pushed into the corner because maintenance could not use that machine anymore. It happens, right? We have to make sure whatever solution that we're adding to this machine, yes, is safe, but also practical. Okay? We want to allow visibility to the machine or process if that's what we want. Right? If we want to make sure that the operators and maintenance personnel can see what's going on, we want to make sure that we are using the correct fixed guardings to do that. Right? And here's an example of how easy it is to see past a black mesh compared to a yellow mesh. Okay, now there's no standards that say it has to be a certain color or it has to be transparent. But again, something to consider when we're trying to look at risk reduction and adding some guards on there. Okay. Now you may have a situation where you have, guards on 3 sides of the machine or even 4 sides of the machine, but we have an area where we need to open up the guard to place a part. Okay. Anytime you have a guard that can open this access guard, well, they need to be monitored. Okay? They need to be monitored. The machine, the system has to know that this guard door is open to put the machine into a safe state. I mean, again, this is all part of this risk reduction. This is just one element of the risk assessment. When we started adding these safety solutions for monitoring a guard door, again, something that's often overlooked is that safety circuit, right? Again, trying to remember we don't want to make a false sense of security. And if you identify a hazard that can have a risk of a fatality, and we say, okay, you know what, we're gonna add some safety solutions. We're gonna add some safety devices on here, and you order a light curtain that is not the proper level of safety. So those of you who understand types of light curtain, you order a type 2 light curtain instead of a type 4, or you only wire up one output to a non-safety monitoring device. All right, well, what have you done really? You've made a single channel circuit for a risk that can cause a fatality. A single channel circuit, one failure, and your entire safety system is out the window. So we have to make sure that we are designing the safety circuits to meet the proper circuit reliability. And this then brings on a whole nother discussion, right? This is a whole nother webinar, another training, because now we start looking into, functional safety and some of those buzzwords that I have listed here, categories and performance levels and safety integrity levels. You need to make sure that those safety circuits are wired correctly. Okay. Once you do that, once you start, making sure that these safety circuits are wired correctly as part of your risk reduction measures, and then you can go back to that question: is this risk, or is this risk low enough? Right? After you've done these risk assessments, let's go back to the risk assessment process, right? And we look at standards, right? What are some standards that are going to help us? So I mentioned already in the last slide, the minute that we start putting up hard guards, there's standards that are available to help us understand the heights and distances of those guards, right? We start adding safety devices and creating what's called a safety function. There's standards to help us understand how to wire up these safety circuits. So the risk assessment, yes, there are standards for it, but it's the first step, right? It's the first step. So we look at the standards. They can be broken up into 4 types. And type A is a basic safety standard, like the risk assessment standard. It's basic. It's giving us the fundamental steps, right? It's giving us the definitions of the risk assessment, giving us definitions of a hazard and a risk. It's giving us some guidance on what to look for as far as the probability of a risk. It's a basic standard to give us some guidance on a risk assessment. What we're going to try to do here is look at this industrial robot from one of our earlier slides, and say, okay, let's try to apply these risk assessment procedures, this process, to this robot. And we know that anytime we see an industrial robot, there's some guarding around, right? Because there's that possibility of fatality. An industrial robot moving at full speed, coming into contact with a human, is going to be rated as a fatality, right? When you go through your risk estimation, okay? So we say, okay, fine. We look at standards, right? In addition to the type A basic standard, there's a type B1 where it looks at aspects of safety. So once we're done with our risk assessments and we start adding safety solutions to perform that risk reduction, well, let's go ahead and add some hard guards. When we're trying to determine how high and how far this guard has to be, that's considered a B1 standard, a certain aspect of safety. Example, ISO 13857. Okay? We have an access guard there. Because we have an access guard, we want to make sure that we're monitoring this guard. So we throw on some interlock. Okay? Because we throw on this interlock, we are creating we're using this B2 standard, which looks at a particular level of safety. And then we bring in the idea of ISO 14119. I mentioned in the previous slide that we start adding these devices. We're creating a safety function that can be ISO 13849 for functional safety. That's the B1 standard, right? That's the aspect of safety. But again, that's a whole different conversation. There is also a Type C standard, which looks at a specific type of machine. For this example, with robot, right, there is a standard that looks at industrial robots, which is ISO 10218. Now, the reason that I go through these examples and list out, type A, B1, B2, and C is to let you know, if you did know, that there may be a type C standard for the machine that you're looking at, the one that you're trying to assess. Maybe there's a type C standard. And we can use that type C standard because it's going to give us the basic guidance to address the hazards that have been identified. Okay, now, in every type C standard, what you will see is a note that says you have to do a risk assessment still. So that still brings us back to our discussion today. Okay, even though there's a type C standard that's available to help guide us on safeguarding solutions, because if you look at, ANSI RIA 1506 or, ISO 10218, they'll give you guidance as far as, making sure that no one can be trapped inside of a full body access area, and give you guidance on the enabled device and the requirements and guidance for your safety circuits, the minimum requirements for your safety circuits, and requirements for light curtains. So it's a great standard to use as far as a type C if it's available to you. But again, they will tell you to do your risk assessment, coming back to ISO 12100, right? Because they don't know how you use this machine, right? They don't know how you're going to use this robotic cell, or it's integrated into something else. So at the end of the day, you still have to do your basic risk assessment. Okay. The next question is who? Who's doing this assessment? And I mentioned earlier, the ISO 12100 is really related to machine builders, and we look at ANSI B11.0. Okay, this is great because it gives us a clear layout of responsibilities and who should be doing the risk assessment. So let's look at that and let's see what that means. Right. So when we're looking at the conceptual design, so as an end user, you're going to the OEM to let them know what you need for a machine, and as an OEM, you're getting the feedback or the instructions from the user about what they need for what they need this machine to do. So now we have this conceptual design phase. This is when a risk assessment should start. All right. So we have this, as we see here, as far as ANSI B11.0 says, there's this potential collaboration between the two, right? The user knows what they need, the supplier knows what they can provide. Let's get together. Let's try to see what hazards may exist during this conceptual design, right? And then we have the design phase, where ANSI B11.0 lists. This is going to be a more detailed risk assessment. Okay, this ties directly back to what we looked at a few slides ago as far as being able to design hazards out. Well, we don't know what hazards we can design out unless we do a risk assessment. Okay, so here's further proof of that process from a whole nother safety standard. Okay, so we have the design phase, we do a risk assessment, and then we go through the build. So now this machine's actually being built. Panels are being on. We're getting power to the machine. We want some FATs, right? Here we can do another risk assessment. Now that the machine is being built, we can now see some additional aspects that we couldn't see with the drawings. Maybe we change the way that we're going to interact with this machine. But here's third stage, a risk assessment. Okay. And then we go to the install commissioning. Right? So now this machine's being delivered. This triggers another assessment. Right? We're on our for the assessment for this machine before we even run it. Why? Because now that we're going to install this machine, we need to make sure that we're not creating any additional hazards, right? So we have to make sure that there's enough space to use the machine. We're not overlapping our work envelopes. There's enough lighting. We're not exceeding any noise requirements. So during this installation commissioning, we have to do another assessment. Okay. Now that the user has now claimed this machine, they now own this machine. Now you have to do an ongoing risk assessment. Okay? A risk assessment is not a one and done deal as we see here. And just because the machine is running and is purchased, installed, and running doesn't mean that we no longer have to do a risk assessment. Okay. So if you move the machine, or in this example here from NCB 11.0, if we do any type of retrofits, we do any type of modifications, this triggers a risk assessment. Right? When we are done with this machine, we're doing a decommissioning, this triggers a risk assessment. We look at some of the earlier standards, some of the wording in there and the descriptions is that a risk assessment is completed throughout the entire life cycle of the machine. Here with this example of B11.0, we see it, right? It's one thing to read it, but now we see it. Here is the entire life cycle of the machine. And here with each step, we need to do a risk assessment. All right. A couple of quick notes. I'm looking at the time. Definitely want to have some time for some Q&A. When we talk about the risk assessment, there are two approaches that you can take, right? And they both need to be taken. They complement each other. And the first thing here is the machine safety risk assessment, all right, where we're identifying the hazards associated with the overall machine, such as documentation, right? So do we have, lockout tagout procedures in place? Is there proper signage on the machine? Let's do a walk around on the machine. Are there any exposed, rotating, crushing, shearing hazards? Are there safety components on here? Great. Are they safety rated? Right? Are they wired correctly? Are there tripping hazards? Again, is there enough lighting here just for me to see what I'm doing? Is there can I see around the machine to make sure that I'm not going to start the machine while someone's in an area, right? So we do this overall assessment for the machine. Then there's also the task-based assessment, where you're identifying hazards and risks associated with each task on a machine. Example, you may have some operator tasks, such as placing material and initiating the machine cycle. So what we have to do is look at what those tasks are and go through the process, right? The first thing that we looked at in slide 2, right? It's define the limits of the machine, right? Define the scope of your risk assessment. So let's look at the operator task, and we look at the hazards and the risk associated with these tasks. Same thing for another personnel on this machine, so maintenance tasks, right? Look at those, and we say, okay, what are the hazards and risks associated with it? Changing some hydraulic oil filters, punch die inspection, what are the PMs that they have to do? Because this is often overlooked as well. And we spend a lot of time looking at the operator tasks, which, yes, we need to, but a lot of time we forget that maintenance, right? R&D, that tool room, they all need to go back home the way they came to work today as well. We need to make sure that they are safe as well. Right? This is often overlooked. So we have to do the overall machine assessment as well as the task-based assessment. Now, there are certain benefits to doing one over the other, but again, they both have to be done. So the question is when, right? When do we do a overall machine assessment, and when do we do the task-based assessment, right? So for the overall, machine risk assessment, it's going to help you identify high risk machines. So if you are doing an assessment for an entire plant, okay, or for a cell, you can do these overall assessments, and then you can identify these high risk machines. If you are doing this assessment on a group of machines that are the same, then maybe you can identify some common issues. But this overall assessment will also allow you to prioritize. All right, maybe these machines in Group A have a high risk estimation, and maybe we need to take care of those first. Where these other machines in Group B, yeah, there's some hazards there, but they're not as dangerous. So we can prioritize. And if it's just a single machine, it gives you a snapshot of the overall hazards associated with this piece of equipment. For the task-based assessment, now you're, again, looking at the specific task. So now we can drill down a little deeper. So your overall assessment, identify those high-risk machines. Perfect. Let's look at these high-risk machines and try to provide risk reduction measures. Before we can provide risk reduction measures, we need to do this task-based to see how people are using this machine. Because you may say, okay, we want to safeguard this area, so we're going to throw on a hard guard with the interlock, okay? And it may be perfect for the design, but come to find out, the operator needs both hands to load the part. So maybe that guard is not the best, and maybe we need to use a light curtain. So this task-based helps you understand what type of device you would need or could use for this risk reduction measure. Okay. Quick summary. So the beginning stages of the risk assessment process is determine the scope of the assessment. Right? We have to determine the limits of the machine. Who uses the machine? Where is this machine being used? Find the limits, and then it's identify the potential sources of harm, which are the hazards. Okay. Then we look at the risk, determine the likelihood of exposure. Those are the risks associated with the harm. And then we have to decide, is this risk acceptable? If it's not, we go through risk reduction measures. And also the note here is make sure to look for a type C standard, because it's going to give you that basic guidance on what to look for, especially if you don't know where to start. Right? So type C standard is great. Again, it's for a specific machine, so not every machine would have a type C standard. The last note that we have here is that the risk assessment is a continuous process. All right. Thank you so much, everyone. Stay safe, and we look forward to seeing you on the next webinar. Take care, everyone.